You have likely experienced the sudden collapse of a reporting workflow, the chaos caused when a manual CSV export fails or an ad hoc script breaks. This compares that reality against the target end state. On the left, a disconnected manual process relying on CSV exports. On the right, an automated platform powered by an API pipeline. Today, we'll map out the framework required to make this transition. This schematic outlines the LADE project, a disciplined maturation path that moves through 3 distinct phases: the proof of concept, the BI prototype, and finally, the enterprise application. Scaling a data team requires upgrading the underlying architecture layer by layer, rather than simply purchasing new visualization software. Step 1 is to audit your current workflow to determine if you are stuck in the proof of concept phase. Phase 1 proof of concepts rely on manual CSV exports, shaped by external ad hoc scripts, represented by the R logo. While this proves insights are possible, the manual repetition introduces a high risk of human error, making it operationally unsustainable. To fix this, we must evolve to Phase 2, building a functional BI prototype. This requires introducing an API. An application programming interface is a digital bridge that allows 2 distinct software systems to communicate, replacing manual human exports with automated data extraction. This Phase 2 diagram illustrates the shift. The API plug icon flows directly into Power Query, moving cleaning logic out of ad hoc scripts and into the internal pipeline. The organization now possesses a refreshable BI asset that updates automatically from the source. Stopping at this phase, however, leaves you vulnerable. While the process is automated, the logic is still dangerously locked inside a single desktop file, creating a silo that cannot scale across an enterprise. Breaking out of the prototype phase requires shifting the heavy processing workloads away from your reporting tool. We do this through Upstream Transformation. This is the practice of cleaning and organizing data directly in the database before it ever reaches the reporting layer. This schematic details a production-grade platform. In the middle panel, logic moves from Power Query into SQL-style shaping within the source system. SQL is a standard language used to manage databases. This ensures data is pre-cleaned before ingestion begins. This chart of strategic advances emphasizes this transition in Box 2. Moving from R and Power Query to SQL directly reduces refresh times and guarantees that logic is applied consistently. Forcing visualization tools to process data causes crashes under pressure. True scale requires the database to handle the heavy lifting. The final obstacle is the danger of building massive datasets inside individual desktop files. The solution is to physically separate the underlying business rules from the charts and graphs that display them. This is achieved by establishing a semantic model. A semantic model is an institution-wide master dataset hosted in the cloud, like Power BI Service, that acts as the single definitive source of truth. Returning to the platform anatomy, the right-hand panel shows this decoupled state. The API pipeline feeds a disconnected semantic model in the cloud. As bullet points confirm, the desktop application now acts purely as a blank canvas to draw visuals. This blueprint displays the final 3-tiered structure of a production-grade platform: ingestion at the base, semantic layer in the middle, and visualization on top. Notice the unidirectional flow. Data is extracted, structured centrally, and finally served to the visualization layer. This decoupled architecture ensures a single, governed master dataset can safely power dozens of distinct reports across an entire institution without requiring developers to replicate code. Navigating from a manual CSV process to a semantically modeled application yields an engine that runs smoothly and continuously. This diagram outlines capabilities unlocked by this architecture. This central data platform enables multiple analytic workflows across the institution. On the left, we see specific institutional wins: true incremental data refreshing aligned with the calendar, and robust governance for security and data filtering. This matrix is the LADE maturity model. You can use it as an immediate diagnostic tool to evaluate your own organization's standing across extraction, transformation, and modeling. Identify your team's current column on this matrix, pinpoint your exact operational bottlenecks, and begin engineering your